Hi, we're here at GSI and now doing a continuation of GM13 for HDPE geomembranes. This is an endurance property, probably the most significant of them, which is stress cracking, ASTM D as in David 5397. And what it utilizes is a dog bone shaped specimen in an incubation bath which is behind me. These dog bone shaped specimens sit in tension on a rack such as this and subsequently are loaded in a bath which is held constant at 50 degrees C. It has HDPE solution in it, which is a wetting solution. It's a surfactant, and this wetting solution is C630 wetting solution. It goes with distilled deionized water at 10% by volume. We'll now show you the critical point of notching the specimen and then come back to the setup of the apparatus. So here we're with a critical point in the test of notching the specimen. This is a dog bone shaped specimen, 1822 type L. And what you'd like to do first is determine the thickness of each individual specimens. You typically do this with a set of calipers. This is reading 1.68 millimeters, and subsequently the thickness to that is 20% of that thickness, leaving 80% of for the ligament. It's done off of this device, which is a rigid device. It's made by BT Technologies. There are other devices out there. There's a very sharp razor blade associated with this. This is honed 3 different times, so the blade is extremely sharp. It's situated here. This is a rigid platen from which the center of it, the specimen, is spanned. You do have to keep the specimen flat. We typically do this with this pointer here, and the thickness is read off of the dial gauge here. You're benefited often by turning this so that you can read the dial gauge on an angle and subsequently shine light behind the specimen. Okay, the notch is generated off of this and subsequently notching of the material. You take the specimen out and subsequently are ready for the next specimen. The notch for this particular case, you can see it. If I bend it, the specimen was notched. But this is notching the specimen. It has to be done extremely accurately, and it's a critical point in the test. And if you want to get repeatable results, this is certainly paramount. Okay, the specimens have been notched, and I'd like to show you how to mount them in the test rig. This is the notched specimen, and as you can see, it goes in the test rig from the lollipop to the stanchion. The stanchion or the platen stays constant, and the lollipop is attached to this rocker arm. The rocker arm, as you can see, can have a weight applied to it. This weight is a given percentage of the yield stress. And I should point out to you that we typically run the appendix. We do not run the full curve. The appendix is at 30% of yield stress, which is determined from a dog bone tensile test, and the notch depth is 20% of the thickness of the material. That leaves 80% for the ligament thickness. You attach this the specimens here. These are intact. This one has ruptured. You'll see that in the slides afterwards. You mount this in the vise like this, and then you place your HDPE solution, 10% HDPE solution in here. We have a heater. It has to be kept at 50 degrees C. We also have a stirrer. This stirrer agitates the liquid and keeps it flowing inside the apparatus. There's also a device to control the water level. This water is distilled deionized water, which is added to the mix to keep it at 10% solution. Failure time is recorded by the clocks on the tops. They're actually here, 5 of them for the 5 rocker arms, and you have mercury switches in the back to trip the timers as you see fit. So the value at the end is time, and it's typically given in hours. So this is a notch constant tension load. Typically run the appendix for GRI GM13, and this is for high density polyethylene membranes only. Okay, signing out from GSI.